Lesson 6 is all about completing the square. We'll find out that completing the square is a process for finding a constant c that we can add to the x terms so that we end up with x squared plus bx plus c, which is standard form for a quadratic. But also what's unique is that this is going to be the square of a binomial. This is the square of a binomial x plus 3. And we have this physical model here. So we don't really know the measurement of this large square, but if it was x, then the area of that square would be x times x, or x squared. And since the height of each little block here is that same unknown x, you see that we have x plus 3, where this is 1, and it's x tall, and this is x tall and x wide. So it's x plus 3 for the length of that side. And continuing on in that same format, this is 1 unit tall and x units wide. This is 1 unit tall and 1 unit wide. So we have 1, 1, 1, 1, 1, 1, 1, 1, and 1. The area is 1, so that area, there are 9 of those. And then on this side, the length of this is x plus 1 plus 2 plus 3, or x plus 3 in height. When we distribute x plus 3 times x plus 3, we end up with the area model x squared plus 6x's plus 9. So our c value would be 9. We were looking for that missing value to fill in here to create the model that we have. And using a little bit of shading, you can see how that physical model plays out, where we have 1x squared and 6x blocks and 9 number cubes for that constant. Now, another useful tool for solving quadratics is called the square root method. And when we're using the square root method, we want to take the square root of the x squared term and the square root of the 9. But remember that when you're doing the process of taking the square root, you have to consider that this answer, absolute value, could either be positive or negative. So I can square a positive 3 or a negative 3 and end up with a positive 9. That's called the square root method. So finding and solving by square roots, if we isolate the squared term, 2x squared, by itself, by subtracting 9 from 13, and then divide by 2, then we can take the square root of the left and both positive and negative square root of the right. So the square root of x squared is x, and the square root of 2 is either positive square root of 2 or negative square root of 2, which is about 1.4. On example 2, same thing. If I take 7x squared to isolate and add 10 to both sides, so I have 7x squared equals 45, and then divide by 7, 45 divided by 7. Next, we want to take the square root of both sides. So the square root of x squared is x, and the square root plus or minus square root of 45 over 7. Now you can rationalize that. Think about 9 times 5 is 3 square roots of 5, and then rationalizing the square root of 7 on top and bottom is going to give us plus or minus 3 square roots of 35 divided by 7. So if you want the exact solution, this is our exact solution. But if you take the calculator approach, that could also be plus or minus about 2.54. So whether you want the exact answer or the approximation answer, either one, you're able to do that. So that pretty much covers the square root approach. Next, some things you want to recognize is the fact that you've got a perfect square trinomial in certain situations and how that can benefit you in solving. So on part A, I see the left is the binomial x minus 7 squared. And because I have two squares on both sides, if we take the square root of the binomial squared, that gives us x minus 7. But you've got to remember you're doing the square root approach, so you're introducing the positive or the negative, and the square root of positive or negative 25 is plus or minus 5. So you've got two situations to solve. X minus 7 is 5, so x could be 12. Or x minus 7 is negative 5, so x could be 2. So we have two solutions, positive 2 or positive 12. In part B, it's similar. X plus 5 quantity squared is equal to 100. The left side is a perfect square, so to get to the variable x, we need to take the square root of the left and both plus and minus square root of the right. So either x plus 5 is positive 10 or x plus 5 is negative 10. If x plus 5 is positive 10, our 0 would be at 5. If x plus 5 is negative 10, our 0 would be at negative 15. Two solutions, negative 15 or positive 5. And then finally in part C, it's a little more complicated, but 4x squared is a square, 9 is a square, and 2x times 3 doubled is 12. So recognition that you have a perfect square trinomial and can write that in factored form, and then use the square root method to eliminate and solve for the variable x. So we want to eliminate that square. And then we have 2x minus 3 is either positive or negative 7. When 2x minus 3 is positive 7, 2x is 10, so x is 5. Or 2x minus 3 is negative 7. In that case, 2x is negative 4, so x would be negative 2. And again, it's quadratic. We're expecting two solutions because the power is 2 and negative 2 or positive 5. So now the reason we have our lesson here, completing the square. If you want to create a perfect square trinomial, just like example 3, then you need to take the x squared plus the bx, and to get that c value, the technique for getting that c value is to take your b value, divide it in half, and then square it. And that way you can factor x plus half of your b quantity squared. This will give you your binomial that's been squared. That's called completing the square. In example 4, we're going to practice that approach. Our b value is 6. Half of 6 is 3. And 3 squared is 9. We would add 9 to complete the square. In part B, the b value is negative 14. Half of that is negative 7. When we square negative 7, your c value would be positive 49. On part C, the b value is negative 24. Half of that negative 24 is negative 12. Negative 12 squared is positive 144. And then lastly, this one's going to give us a fraction. The b value is 5. Half of 5 is 2.5. I prefer to keep the fraction there. It's much easier to square by saying 5 squared over 2 squared is 25 fourths. So we have c values that can be found for completing the square method of solving quadratics. We'll try those out in our next example. You can see here that I've given you a procedure, 8 steps on how to solve an equation by completing the square. First, we'll start out with an easy one where the leading coefficient is 1. Using that technique, we want to take half of the middle term, square it. The middle term is 12, it's negative 12. Half of that middle term squared, negative 6, is going to be positive 36. So x squared minus 12x plus, I'm going to make a box here, and subtract the 7, and think about it this way. Whatever I do to the left, if I add 36 to the left, I have to add 36 to the right. So this perfect square trinomial now factors as x minus 6 quantity squared, and 36 minus 7 is 29. Taking the square root of the left and both positive and negative square root of the right, we have the exact solution by solving for x, which is going to be 6 plus the square root of 29, or 6 minus the square root of 29. I'm going to write the answers combined. But if you wanted a decimal approximation, your two answers would be 6 plus the square root of 29, which is about 11 39 hundredths, or 6 minus the square root of 9, which is about 61 hundredths. So this is your approximations. These are your exact solutions. Now it's a little trickier when you're completing the square and the leading coefficient is not 1. The first thing you need to do is divide each term by 2. So we're dividing, let's make a note of that. First we want to divide by 2. So 2 divided by 2 and 2 divided by 2. And we're going to complete the square. We're going to subtract, the subtract 9 is now going to be added to the right, but we're dividing by 2, and then we're going to complete the square. Okay, so now we have the middle term. We want to know half of the middle term squared, and the middle term is 1, so half of 1 squared is 1/4. We're adding 1/4 to the left and 1/4 to the right. But remember, our factored form is x plus b over 2. And 9 halves plus 1/4 is going to be 19 fourths. Now we want to take the square root of the left and plus or minus square root of the right. So the square root of x plus 1/2, quantity squared, is x plus 1/2. The square root of 19 fourths, I can't take the square root of 19 without using a decimal, but the square root of 4 is 2. And how convenient if we take x equals negative 1/2 plus or minus the square root of 19 halves, you can put that together as negative 1 plus or minus the square root of 19 divided by 2. This is our exact solutions. There's 2 of them, but if you break them apart using our calculator, being very careful not to ungroup the numerator, we got negative 1 plus the square root of 19, and that answer divided by 2 is 1.68. And then you have negative 1 minus the square root of 19. That answer divided by 2 is negative 2.68. So you can have exact solutions and approximations. Here's one that's really tricky. So first thing, divide through by 4. We need to get rid of the leading. That's going to give us x squared plus 10 over 4x minus 3 over 4. But remember, I want to complete the square, so I'm going to add the 3 over 4 and get ready to complete the square. So put your thinking cap on. If we take the b number, which is 10 over 4, and we cut that in half, we have 10 over 8. Now, reducing 10 over 8, that would be 5/4. So b over 2 is 5/4. The square of 5/4 is 25/16. We want to add 25/16 to the left and to the right to complete the square. 25/16 added here and here. Next, we want to factor the binomial. That's x plus 5/4 squared, because remember our binomial is the b over 2. And 3/4 plus 25/16 would be 12 and 25, so that's 37/16. Next, we want to take the square root of the left and the plus or minus square root of the right. X plus 5/4 quantity squared under the radical gives us x plus 5/4. And 37/16 under the radical gives us plus or minus radical 37 on the top. And the square root of 16 is 4 on the bottom. So our exact solutions, if we subtract 5/4, we have negative 5 plus or minus the square root of 37 over 4. And going to our calculator, separating the terms, negative 5 plus the square root of 37 divided by 4 is about 27/100. And negative 5 minus the square root of 37 divided by 4 is about 2 77/100. So that was a really tricky one with this b over 2. You had to really think about that because we're cutting a fraction in half. 5/2 cut in half is 5/4. In example 8, let's look at writing in vertex form. So completing the square is great for that when you have to graph. You can complete the square and know your h and your k value. So think about example 8. If we have x squared minus 6x, I'm just going to think about these two terms grouped together and just kind of say to the positive 3, scoot over there a little bit, because we want to complete the square here, but whatever we add inside the parentheses, we want to subtract it outside the parentheses because we're keeping everything on the right side. We have y equals on the left. So we're not going to put this number, add it over here. We're just going to add that number and subtract that number. So taking that into account, we've got half of the b. So our b is negative 6. Half of b is negative 3. Negative 3 squared is 9. So we're going to add 9 on the inside and subtract 9 on the outside. Adding 9 here, subtracting 9 here. We've added up a 0 there in that case. And then factoring the parentheses, x minus 3 is our binomial squared, and 3 minus 9 is negative 6. And that's the beauty of completing the square. We know our vertex is 3, -6. And we know from looking at standard form, we know our y-intercept is 0, +3. Then our last example, you have the lengths of the sides of a rectangle. It's a rectangular window, and it has the ratio of 1.6 to 1. The area of the window is 2,822.4 square inches, and we want to know the window dimensions. So if we draw ourselves a picture of the window, and we know that the ratio is 1.6 of something, and this is 1, we know that the area is length times width, and in our model, the area in terms of x is going to be 1.6x times the ratio of 1x. So our area model is 1.6x squared. But the area was given to us as 2822.4. So we can use substitution and divide by 1.6. We have x squared is 1,764. Now we want to solve for x, so we're taking the square root, and normally you would think you want the plus and the minus, but when you really think about it, you understand that the negative answer doesn't make any sense. We can't have a negative length on a window. So our x is just going to be the positive answer only, and our measurement units are inches. So the window is 42 inches wide. So we're going to do the dimensions here. We got 42 inches wide by, and then we're multiplying 1.6 by 42, and that makes the window 67.2 inches in length. So we know the measurement of the window. And that's the end of completing the square in chapter 4.